then we can just start getting on with this, and hopefully we can use the hour and a half and finish it. And then I think I will schedule time on Monday as well. I think you guys are writing on Tuesday. Um,
Yes,
so
between 8 and 10.
okay, so I'll schedule some time for us on Monday, even if it is during the day. I'll ask on the group as well, because probably most of you will be able to take study leave or something like that. But let's just and then have an hour that it's just a question and answer kind of session, that anything that still needs to be cleared out, you can ask. So nothing that we prepare for it, but if there is then questions that you want to post on the group and we need to address it, we can do that. Okay, so let's look and try to finish the mock exam. I think, can you see the screen?
Yes, we can.
Okay,
Yeah.
cool.
Yes, thanks.
Okay, so basically this is where we stopped last time, and I was saying that, oh, okay, so why do we have 2 here that is independent, or have I made a mistake and things like that? But actually you need to work out both of them to see which one is independent and which one not. And the rule for independent is that something is independent if a probability of A times the probability of B is basically equal to the probability of A and B. So if that is true, then we know something is independent. So we basically need to make a sum for the first one, or calculate it, and then we need to see if it's correct or not, and we need to do it for the second one as well. So for the first one, and let's erase that so that we can see better. So for the first one, we need to say what's the probability of AU, so what's the probability of a person being in Australia. So it will be 102 divided by the 580. And then
It should be 102 and not 120.
Okay, cool. Thank you. (102) divided by the 550 times then being female, and female is 260 divided by 580. Okay, and then if you multiply that out and divide it, you basically get an answer of 0,079. So now we need to check if that is the same as the probability of A and B. So we need to check if it was the same as 52 divided by 580. Okay, and when we say 52 divided by 580, we will get the answer of 0,09. So for that one, we know the 2 is not equal, so it will not be that one. So actually, we only sit with that one left, but let's work that out as well. So here we need to say the probability events of the UK. So it is 319 divided by 580. And also still female. So it is still the times the 260 divided by the 580, and that will give us 0,247. And then we need to check if the AND is the same. So when we say 143 divided by 580, we actually get 0,247. So we know then that this one is the correct one. Okay, so when we originally started with this, I never thought that we actually needed to work out anything. I thought we could just eliminate by knowing what is mutually exclusive and what is independence. But actually you needed to work out two formulas and decide which one then is correct. Okay, so this was a bit, not a tricky one, but you needed to make some calculations. What they can also do, and I just want to check, so they could give you already the probabilities within the table. So just remember that as well. So they could have replaced the 52 divided by the 580 with a percentage already, so that you can just multiply the percentages. So remember just that they can, instead of a 102, it could have been what 102 divided by 580 is. So just remember that they can do it that way as well, and that you can then still get to the same answer. Okay, so let's see what they are asking us in question 10. So still looking at the same data, and then we're asking us which of the following statements is incorrect. Okay, so let's, I nearly wanted to say, is there anything that looks easy to eliminate? Which of the following statements is incorrect? Oh, okay, so it doesn't seem like it. So let's rather just, did we work out anything here? So here we worked out what was the probability of AU and female, AU and female. Okay, so at least AU and female was 0.9, so at least we have that one correct. AU and male. Okay, so let's quickly, AU and female. That is interesting. Would that actually be the same, but it is rounding off? Sure. So let's quickly. Okay, so actually, so that would have been 0,086. And obviously then if we round it off to 2 decimals, it does give us the 0,09, which is strange, but because it is so close to one another, so that one is correct. I thought maybe it would have been incorrect, so I just thought that maybe would have been the easiest one to see that is incorrect. Okay, so it's not. So again, if it was 3 decimals and they had 0,090, then it would have been wrong. But looking at it, and it is 2 decimals, it is actually correct. Okay, so unfortunately, then let's just start from the top and work down. So what is the probability of male? That is basically 320 divided by 580. And that is equal to 0,55. Probability of being UK. See, so again, it is very close because it is 319 divided by 580. So those two will also be the same if you round it off to 2 decimals. Okay, so those two are correct. Okay, so let's then look at what's the probability of UK and male. So probability of UK and male is 176 divided by 580. So 176 divided by 580 is 0,3, so that is also correct. Okay, so let's look at what's the probability of UK given that the person is male. Okay, so how I normally look at it is, what is the probability of UK given that it is male? So I would have said, what's the probability of UK? So it is 476 divided by 320. That is what I would have done. So let's just make that a bit. Which is actually 0.55. So unfortunately, okay, so that is going to be the wrong one. But let's look at UK given female. So UK giving female is for 143. So 143. Oof, sorry. Let's just. $143 divided by 260. Okay, and the reason why divided by 260, because they tell us it is given that you are female, what are the probability that you are in UK? So 143 divided by 260 is also 0,55. A lot of 0,55s, but they give us it as 0,25. So this one is the wrong one, because we would have said this is also 0,55. Okay, so basically, I couldn't find here any shortcut for you to look at. So it is all start from the top or start from the bottom and see which ones. I thought personally that was weird that you have those ones to all be equal, but it makes sense. And then the option 5 was the incorrect one. Okay, are you happy with that before we move on to the next section of probabilities?
Yeah, perfect.
Okay, so the next section of probabilities. So which of the following statements is correct? Okay, so there's, okay, this is interesting. So probability that you need to work out, probability that you need to work out, estimated, or the mean and the mean. So it's probably one of those two, but both of them can also be incorrect. So if it is saying correct, it could not, if it was incorrect, then I would have only looked at those two and said, okay, but one of them needs to be incorrect. But if we're looking for the correct answer, it can be any one of them. So there's nothing really that we can eliminate. So let's look at from the top, and let's just look at the options. So the sum of all the probabilities must be equal to 1. So that one is incorrect. So let's just check if it is actually equal to 1. So 0.05 plus that is 0.2 plus that is 0.4 plus that is 0.65 plus that is 1. So at least we know everything does add to 1. So the first one is incorrect. Probability that x is smaller than 1. So smaller than 1 means then actually you only look at probability of x equal to 0. So that should be 0.05 and not 0.02. So that one is also incorrect. Then probability of x bigger or equal to 1. So let's use a different color. So probability x bigger or equal to 1. So it is from there. And smaller or equal to 3, so it is that whole area. And that whole area is 0.6. So that one is also incorrect. If the probability was written as this, then it would have been 0.2. Okay, because then we would have said probability bigger than 1. So let's do it this way. So probability bigger than 1, so it's from there. Probability smaller than 3 from there, so it would have been only that portion, which would have been 0.2. So if there wasn't the bigger and equal to, then it would have been correct. But for now, that is incorrect. So we are only sitting with the other two that are possibilities. Okay, so, and for this, unfortunately, you need to make the calculation. So to work out the mean basically is you take the x, multiply by the probability, you add, then the next one multiply, next one multiply, next one multiply, next one multiply. So basically the 0 times the 0.05, so that would be 0 in any case, so we leave that one out. 1 times 0.15 is 0.15. 2 times 0.2 is 0.4. 3 times 0.25 is 0.75. And 4 times 0.35, I need to just calculate. It is 1.4. Okay, so if we then add all of that together, we get that the mean is equal to 2.7. Okay, so that one would have also been wrong. So a correct answer would have been option 5. Okay, so they could have also included here the mean, not the mean, the variance to calculate that. But I think again that is, it makes it longer for you so again, it's one of those that adding that as an option and you need to work it out adds nearly 3-4 minutes to it. So the chances that they will add it is probably very slim. So, and if it was added, I would then first look at the other options, just so that you don't need to take that longer to work out the variance. So if then the other options was wrong, you know the variance is the correct one. Okay, happy with that kind of questioning as well, because this is I think nearly the way that it will be in the exam as well for this type of question. Okay, so that was your normal discrete probability. Then this was an interesting one, the binomial. So it's weird that normally the binomial, the ones that I've now seen in the previous papers as well, where they ask actually not you to use certain things. So and I thought maybe here is an easy way of calculating this. So what did you guys do, the ones that did the mock exam? How did you tackle this one in the mock exam? Did you use the table?
John, on my side, if I remember, I think I just popped those values into the binomial calculator.
So you basically worked out the function. You used the formula.
So what I did, and I'm sorry, it's actually so far back that I've done it. So I found something. So because I don't have the correct calculator, I got this actual binomial calculator on the web, and I just popped in, if I remember correctly.
Oh, okay. So, and
Yeah.
please, but that's an awesome hint as well. And that's why.
Send us a link.
Yes.
Sure thing, absolutely.
No, send the link, and I think it is online. So who on the group was also using Minitab or something like that, but it cost freaking lot of money. But it's because it is online. Use other mechanisms for these kind of things. I think this is nearly the only year that you will have opportunity to use other things to get to the answers as well. And that for me is not, you're not asking somebody else, so you are just using other tools available to you. So please, because to put it in a calculator or to use a table, because I would have probably looked at the table to do this. So I would quickly explain how I would have done it on the table. But yes, I think that is actually a good way of doing it in the exam. And now that I see the table that I have doesn't include n up until 20, so I just want to get myself one that does. Okay, so now I need to go back to the study guide to actually get to that. Okay, let's go to the study guide. I thought I had the table that could have easily given me what to do. Because, yeah, I would, again, if you look at that option, so let me go to the...
What table are we looking for?
I'm looking for the binomial table. So I'll share this screen now when I get to it. In my study guide, so okay, cool. So let me quickly, I just want to write down certain things, and then, so South African MSc knows that the turnout rate is 91%. Okay, so we've got that. In a random sample, 20 voters, so we've got N, and that at most 13 will turn out. Okay, so let me share the binomial screen. Okay, so, and now I don't know if we can be able to turn it around. Okay, that now is something to look at, but let's quickly, so how the binomial table works is at the top you have if the probability is from 0.01 to 0.5, and then you read it from the perspective of n going down from 0 to 20. Then if you get like we had now 91, you will use the bottom part. So there will be the 0.91, the 90% or 91%, and then you use it as 0 to 20 and moving upwards. So basically what the binomial is saying to us is that the 0.01, you get 4 of them. So if it was 0.01 and you would have said where n is 20 and you had 0 or more, you would look at that point. If it was 0.99, you would have worked from bottom up and you would have looked at that point as your other value. Okay, so let's look at 0.91. And unfortunately, I don't now be able to draw across it, but they tell us at the 0.91 probability, we're working with n is 20. We want to find out at most 13. So at most 13 is 13 and less. Okay, so basically we need to say, we need to add up the 0.0046. So is it possible to draw that? Huh. Okay. So let me just check at most. Okay. So we need to add all of them together. Okay, and that will give us, let me quickly check, hopefully I can get the answer for that, 0.016 plus 0.0046, if I'm reading it right, plus 0.0011 plus 0.0002. So basically what I have is, so let's just check if I did it correctly. Oh, wait, I'm at 0, I'm at the wrong one. I'm at 0.85. I need to be there at 0.91. Okay, was just wondering what I am calculating, sorry. Easily how I made that mistake. So again, we are, just want to check, we are at 13. So basically it is 0.0011 plus 0.0002, which give us 0.0013. So then if I share the other slide again, 0.0013, so that is basically option 5 that we have. Okay, so yes, use a calculator, online calculator if you can. I think that is, you will be able to do that. So please do that. But if you don't have a calculator and you need to work it out, that is a way to do that. Okay, happy with that. And I think it's also good that you now have seen how I use the binomial table to get to the answers. Okay, is the screen back again with the questions?
Yes.
Okay, cool. Okay, so let's move to the next one. So again, if you look at the probability, the discrete at one question, binomial at one question, and then there's one for Poisson distribution. So it is, you will get one of each. So yeah, so there's nothing in here that is how it will be. So I think that's at least a given. Okay, so let's look at what do they give us in the Poisson distribution. So suppose the number of voters entered a voting station in the UK per minute is Poisson distribution distributed with a mean of 0.25. So we know that the lambda is, 2.5. Which of the following statements is correct? Okay, so again here we will go to the table. So at least I've got a table next to me, but if you go to the study guide on page 93, there's the Poisson table as well. We would look at the Poisson table where it is, the lambda is 2.5. And then we would look at, okay, so what's the probability that exactly 4 voters will enter the voting station? So we will look at, and let me quickly just share that also, that we get that practice in again. Sorry, wrong one. Okay, so then if we look at lambda 0 or 2.5, exactly 4. So exactly 4 is, I want to check, the question was the probability that exactly 4 voters, so exactly 4 voters is 0,1336. Okay, so let's quickly check my options. My options for the first one is 0,2138. So we need to look for the correct one. So that is not the answer. Let me quickly then show the probability that, so the next set of question is the probability that no one will enter the voting station is given minute. So no one is 0. So what's the probability that no one will enter the voting station is actually 0,0821, and they said it is 0, so that is also the incorrect one. I will now project back again the questions. If X is the number of voters entering a voting station in a given minute, then the variance is 2.5. Okay, so let's just quickly share that again. Okay, so if X is the number of voters entering a voting station in a given minute, then the variance is 2.5. Is that true or not? What can you remember the rules of that? Okay, so that is actually true. So the mean and the variance of a Poisson distribution is exactly the same. So that is correct. So that's actually out of the definitions, the mean and the variance of the Poisson distribution is exactly the same. So that answer is correct. Okay. So the other two, again, we will look at the table. So let me, I don't want to switch back to the other one so if X is the number of voters entering a voting station in a given period, between smaller than 1 but bigger or equal to 0. So smaller than 1, basically you exclude 0, you exclude 1. So smaller than 1, you exclude 1, so you're actually only looking at 0. So that answer then should be the 0,0821, which should have been the same as that one. So you can see that is basically asking exactly the same question. The last one, if X is the number of voters entering a voting station in a given minute, where X is bigger than 0, so it doesn't include 0, but it's smaller than equal to 1. So basically it only looks at what's the probability that X is equal to 1, and that is 0, if I look at my table, that looks like 0,052. My table is a bit blurry, but that is what I think my table says. So then we know both 4 and 5 are incorrect, and 3 was the correct one. Okay. So if they don't give you the Poisson table, then you know actually that only option 3 could have been the right one, because you needed to use the table to calculate 1, 2, 3, and 1, 2, 4, and 5. So it has happened before in an exam, but okay, you have a table, so it doesn't matter for you in this one. So ignore that comment, because you actually have gotten all the tables and formulas beforehand. Okay, so with this one, we didn't need to actually use the table, because we know that the variance and the mean are exactly the same. So the correct answer is option 3. Okay, so let's then go into normal distribution. So, and in normal distribution, it is that you can see, let's quickly check how many questions. There's much more in the normal distribution side, because I think there's 2 or 3 chapters on that. So normal distribution, there's lots more of questions in the exam. So let's quickly look at the first one, question 14. Which of the following statements is incorrect with regard to the standard normal distribution? Okay, so now this is definition stuff again. So the standard normal distribution is symmetric around the mean. That is correct. So we are looking for the incorrect one. The standard normal distribution has a mean of 0 and the standard deviation of 1. That is correct. The standard normal distribution is discrete. That is incorrect. It's definitely not discrete. The area underneath the normal curve is 1. That is correct. A normal distributed random variable x can be standardized according to a formula, that which is correct. Okay, so the incorrect one is that one. The standard normal distribution is definitely not discrete. Let me show you. That was discrete. So you know for x1 there's a probability, for x2 there's a probability. If we look at normal distribution and you look at the table, you can see that it's not discrete, because you get for an x that is equal to 1.1111, there's a probability, etc. Okay, so normal distribution is definitely not discrete, so that is the incorrect one. But this was purely, again, a definition type of question, so it seems like they will include definitions into your exam paper as well. Okay, let's look at the next one. Consider a normally distributed random variable x with a mean of 100, the variance of 25. Calculate the probability that x is between 115 and 105. Okay, so we need to calculate that. So we need to work out with that function basically what the 2z values will be. So we will say, okay, so we've got the mean is equal to 100. variance is equal to 25. So if variance is 25, remember that the standard deviation then is equal to 5. So that is an area that one can easily make the mistakes, so that you use the 25 instead of a 5. So we will basically need to work out using that formula. So first Z will be the 105. Okay, so let's just look at that formula, x minus mu. So that is for x. That must be okay. So let me just write, so we will need to work out that. So I don't need to go back to the previous one every time. So 105 minus 100 divided by 5. So we're turning it into a Z. So here it will be 115 minus 100 divided by 5. So we're going to work out, seems like, what is the probability. So 105 minus 100 is 5. 5 divided by 5 is 1. 115 minus 100 is 15. 15 divided by 5 is 3. So we need to work out what is the probability that Z is between 1 and 3. And let's just, that is Z and not 2. But we don't confuse that as well. So what's the probability that Z is between 1 and 3? So that is basically what you are looking for. Okay, so when we look at that, then you nearly say, well, it can't be, okay, can't be 1, because you needed to have a minus 3 there as well, etc. So it can't be 1. It is definitely, if you look at that, it is going to be something that is probably going to be smaller than 0.5. Because if we look at the Z table, and Z of 1 is going to be, so Z of 0, so let's even include that. Z of 0 makes that part 0.5. So Z of 0 makes that part also 0.5. So it needs to be less than 0.5. So it can't be one of those two. So if we needed to guess, basically we can guess one of those two, and it is very close to one another. So let's work it out. So what I'm using is, then to get to that area, I just say, and I nearly want to, so let's take that away. So what I'm going to do is I'm going to say, let's take the whole area up until 3, and let's minus the whole area up until 1, and then we will get basically what the other area is. Okay, so from the tables, the probability of Z equal to 3 is 0.9987 minus the probability of Z equal to 1, which is 0.8413. Okay, and if we subtract those two from one another, 0.9987 minus 0.8413, we get 0.1574. Okay, and then we know option 2 is the correct one. Okay, so yeah, no easy way to get to that. You basically need to work out what is the Z value for the 115. You need to work out what is the Z value for the 105. Need to get the two probabilities of that and subtract the two from one another. Okay, happy with that.
All good.
It needs to sink in a bit as well, but that is, yeah, I think this is nearly the most difficult way they will ask it. Okay, let's look at the next one. Consider the standard normal curve. Okay, so they tell us this area is 0.5. Okay, so they tell us that area is 0.5. Then what is the value of Z? Okay, so what would you do here? Anybody? Or was this one of those that also was a bit of a weird one? Was it a difficult one? So let's quickly, so if that area is 0.5, what is that and that area?
0.25 and 0.25.
Also 0.5.
Okay, so that area will be 0.25 and that area will be 0.25. Okay, so we are looking for a Z value where the probability is 0.75. Okay, so we can use the table 3, and then we can, in the table that shows us probabilities, and maybe I will quickly bring that table up for you, and then let's see if we can get the answer. So let me quickly okay, so where that was normally on page 120. 20 or something like that in the study guide. What page? 121 on the study guide. So let me quickly share that. Okay, so we need to look for a probability of 0.75. So when I look at this, I'm like, okay, 0.74, 0.74, 0.74, 0.75. So nearly in between these two is my 0.75. So I've got a value of Z that is equal to 0.6, 0.67, and if we want to be very technical, it lies between 0.07 and 0.08, so let's say 0.675. Here's my Z. But if it is 0.67, I will also not be too worried. So let's go back to the options. Okay, and voila, there is our 0.675. Okay, so that is my correct answer. So by basically looking at my table, so I needed to firstly work out that is 0.25, so that I know that area then is 0.75. And then I needed to go to my Z table, let's do that better. Needed to go to my Z table and then use that probability of 0.75 to get a Z value, and that is for 0.675. Okay, so this one was working it nearly backwards to get to the answer.
John, I'm struggling with this one. I'm not sure how you got to 0.75. I know you plus how you got to 0.75. I know you added 0.25 plus 0.5.
Yes.
But why?
Okay, so let's do that. Okay, you know that area is 0.5.
Yeah.
Because they tell you. Okay, so they tell you that area between the negative Z and the positive Z is 0.5. Okay, then from probability, we know that everything underneath the curve must be equal to 1.
Yeah.
Okay, so that tells me this area and that area must be equal to 0.5. Okay, because if a whole area is equal to 1, I subtract with 0.5, the areas that are left must be also then 0.5. So that 0.5 is this area and that area. Okay. Then because of the normal distribution that is symmetric, we know this side is just as big as that side. That is Z, that is minus Z. So this area and that area is exactly the same size. So that's why we can say 0.5 divided by 2 will give me this size, and it will give me that size, which is 0.25. So now I know that area is 0.25. So if that area is 0,25, that area 0,5, then I know that whole area is 0,75.
Ah, okay.
Okay.
Got it.
So what they are actually using in this is a few things. So they actually testing that you know what symmetric means. They're testing that you know that everything underneath a curve is equal to 1, so that you can work out what the other size is, or basically what that portion of a graph is. Okay, happy with that?
Thank you so much. Yeah, that helps a lot.
Okay. Please, if anybody else have questions, this is now the time to ask it, that we can, because I think when you once understand it, then it actually makes it just so much easier to look at it from the other graphs as well. Okay, so another normal distribution. So it's not that there's even a break on this one. That's another one. That's, okay, so at least that is confidence interval. Okay, so let's look at question 17. A month after cyclone, whatever cyclone, Durban in South Africa experienced severe flooding with mean rainfall of 165 millimeters, standard deviation of 0.76 millimeters. If a sample is 10, okay, so we know the mean is 165. So we know the mean is 165. Standard deviation is 76. We know n is equal to 10. Rainfall measures are normally distributed. Calculate the probability that the mean rainfall measurement will be at least 100 millimeters. Okay. So how would you do that? Okay, so what we would do is, again, we know the formula is 1. Let's just get, okay, so let's just get the formula right again. Okay, so that is something like that. So stop me if I'm making a mistake somewhere. So it's 165 minus 100, and just also probability, that we don't forget what we're looking for. Probability bigger or equal to, okay, so 165 minus 100 divided by,
sorry, John.
Yes.
Is it not 100 minus 165?
Yeah, thank you. Yes, it is. Thank you. Yes, X is awesome. Thank you. I was wondering why that looked too good to be true. Okay. Perfect. Thank you. So it is 100. So just that must be the same. So it's 100 minus the 165 divided by 76 divided by the square root of 10. I hate this because that tells me it is not going to be a nice number to work with, so we will probably need to round off. So
it's negative.
Yes.
I was saying it's negative 2.05.
Okay, that will be cool. So let me quickly check as well. Did anybody else?
2.705.
2.705.
Yes.
Okay. 05. So then probably we need to look at minus 2.71. So let's quickly just check this. So okay, so okay, so let me I'm just gonna check on my calculator. So I got, and we'll now see there's two different answers. So when I rounded it off to 4 decimals, so this is also, and hopefully in the exam it won't be something like this. So when I rounded it off to 4 decimals, I got that. And then if I round it off to 2 decimals, it's actually 2.70. So let's just see. At least it doesn't seem like they are that. So let's look. So we've got the minus 2.7. So let's see if it's 2.70 or if it's 2.71. And we want it to be bigger than that. So we're looking for that area. Okay, so they tell us it needs to be bigger than that Z. So it can't be that one, can't be that one. So I would go to my table. I would look at minus 2.7. I got 0.0035, which was actually that one. But I need to say, because I'm looking, that is that portion. So to get the bigger area, I need to say 1 minus 0.0035, which is then 0.9965. Okay, which is option 2. What I hate about this one is, depending on the rounding, you could have had then the answer of 0.9966. So it's very close, which could have then made you go for option 5 instead of option 2. But also in the exam, if it is off by 1 decimal, then I would go for the answer instead of none of the above. I would go for that one that is 1 decimal away, because that tells me that it was probably something small like that that made the difference. So for question 17, the answer was option 2, the 0.9965. Okay, and I think what is, if I made it 165 minus, I would have gotten option 1 as the option. So if I continued with that, I would have gotten the it as being positive 0,2 or positive 2.7. So then I would have gotten that I needed to work out that small area, which would have gotten me option 1. So again, thank you. It is just make sure that one doesn't make that small mistake, because that small mistake will give you in the end, unfortunately, an option to work with as well. Okay, happy with this one? Okay, let's go to the next question. I'm like wondering where the t values need to come in. So I'm like always hesitant to say where's the t distribution, but luckily not yet. While some victims of a Durban flooding require temporary shelter from government, some had relatives willing to house them. The proportion of victims who needed temporary shelter was 0.6. Okay. If a random sample of 60 victims is selected, calculate the standard error of proportion. Okay, standard error of proportion. So let's quickly, I'm going to see if that part is in your tables. Okay, so I'm also going to my notes that I've made somewhere, because that's a bit, I can't remember all of these formulas. So let's quickly check standard error of proportion. So that is divided by.
Eugene?
Yes.
Just a question. I want to check with you. Maybe I might be wrong. Oh, okay. You have done the square root. It's fine. Okay.
Yeah.
I'm covered.
Okay. Cool. Okay. So let's do that whole thing, and that is the pi, or whatever we call it. So now we need to substitute. So 0.6. 1 minus 0.6 will be 0.4, and it is divided by, where's n, 60, and where is that still? It looks a bit weird, but trust me, it is a square root, so it's 0.6 times 0.4 divided by 60, which gives us 0,004, which actually there's the answer for that, but remember we need to square root still, and then you get 0,0632. Okay, and they only round it off to that, so we have it there. So option 1 is the correct one. Okay, but see again how easily one could have, while you're working on your calculator, one of the options would have been the 0,04. So easily one can make that mistake to say, that is my answer, instead of going to the next one that you still need to square root. So this is the thing with this subject, is there's nearly, for each one that you think there can still be another option. So you could have gotten the 0,04, and there will be that answer for you on the paper. So just again, how you need to concentrate in the exam. Okay, let's go to the next one. What is the critical value for estimating 99% confidence interval of the mean when the standard deviation is unknown. Standard deviation unknown. Yeah, finally we have a t. Okay, so we need to go where the t is, the degrees of freedom is. What will your degrees of freedom be? N minus 1. So it is 10 minus 1, which is equal to 9. And we will work with 99. So let me share the t distribution table with you so that we can quickly sort that out as well. Okay, t distribution. We know the degrees of freedom is 9. They tell us that we're working with a 99% confidence interval. So what is alpha? It is 1 minus the 99%. So that is 0,01. So what would you have said? Do we look at degrees of freedom 9 and 0,01? So what did you guys? Okay, so let's keep those two figures in mind. So let's look, the one is 0,821, the other one is 0.25. Okay, so let's go back to our options. Let me share the screen again. Okay, so remember the two numbers that we had, 0,25, 0,821. Luckily, we only have a 0,25 here. So remember, 99% degrees, or 99%, so 1 minus the 0.99 will give us for alpha, which is 0,01. But because we're working with confidence interval, we still need to divide by 2, which gives us 0,005. So we need to look for the value where the degrees of freedom is 9, your alpha is 0,005, and that value is then the 3,250. Okay, so luckily there wasn't the option for the 0,01 because that would have made it a bit more difficult. But remember, we are working with a confidence interval. So when we use the 99%, we still need to divide by 2 because there's a lower confidence, there's a higher confidence, so there is 2 parts of it. Okay. So for question 19, 99%, but we need to still divide it by 2. Okay, so I think that was the catch in this one. You're working with the degrees of freedom of 9, but you need to look for 0,005. Okay. So then the next question, and now we need to see what they tell us. Okay, population proportion. So when we see proportion, it is always Z. So in a sample of the 60 Durban flooding victims, 36 of them needed shelter. Calculate that confidence interval. So the confidence interval is P plus minus Z, and let me again see what, luckily this was also as one of the formulas, Z times P1 minus E divided by N, and you take the square root of that. Okay, so P we know is the 36 divided by 60. So let's quickly see what is that answer. 36 divided by 60 give us 0.6. Okay, so we have 0.6 plus minus 95% confidence interval is always 1,96. And then underneath that, now we have 0.6 times 0.4. It feels like we have calculated this in the previous one, but let's just do it again. Divided by 60, and we take the square root. Did we do it? So we did do it there. Okay. So just to make sure again, 0.6 times 0.4 divided by 60 is the 0,004. So again, if we take the square root of that, we get, and now again we need to just make sure what the rounding off will be. So it will be 1,96 times, I always go to 4 decimal places just to make sure. So that times 1.96, so we sit with 0.6 plus minus 0,124. So the smallest one is 0.6 minus the 0,0124, which gives us 0,476. Okay, so we're working with rounded off to 2, so let's round it off to 2 decimals. So we sit with 0.48 as the lowest one, and the highest one then is 0,72. Okay, because it will be 0.6 plus the 0.12, which gives us 0.72. So option 2 will be your correct answer. Okay. Again, no shortcuts here. It is basically what you need from the start to work with a formula to work it out. Okay, guys, happy with that? So
yes, thanks.
All good.
Cool. So there's not really a catch in here. It is just a lot of calculation in this one. And maybe if you'd done it here, you could have used that already nearly because it would have helped you. Okay, so now we get to hypothesis testing. So let's quickly see on hypothesis testing, there is 2 then there's only one. Oh, so there's only one on chi-square. Okay, interesting. And 2 on correlations. Okay, or on a regression. So let's quickly, I said we'll continue. So let's finish this mock paper. If it goes a bit over time, it's fine. Then we at least know it's done. So consider the following theoretical hypothesis test about a population mean. H0 or null hypothesis is that, alternative is that. Which of the following statements is correct? Okay, so a one-tailed test is applicable? No. Why not? Because if it is not equal to, we basically have a top and a low, so it will be a two-tail. So whenever you see that, or whenever you rather, let's do it this way, whenever you see that one, it is two-tail. So option 1 is incorrect. So let's look at, if a standard deviation is known, it is definitely not a T, so that is also incorrect. So let's look at the next one. If a standard deviation is unknown, then the test statistic is Z. If it's unknown, it should be T. If it's known, it should be Z. So also wrong. Then, assuming a Z test is applicable, we reject the null hypothesis when Z is smaller or equal to minus Z, or Z is bigger or equal to Z, i.e. two-tail rejection rule. Okay, so that is probably the answer. Assuming a Z test is applicable, we reject the null hypothesis, that one-tail rule. So we know it's not a one-tail, it's a two-tail, so it needs to be that one. Okay. Okay, happy with that?
Yes.
Okay. Phew, this was quite, so this is really definition type of question. So actually a lot was in here about the definition. Quite interesting. This was quite, yeah. This is the first time I'm seeing one of a question like this. So just to, okay, so let's look at the next one. And we need to look for incorrect. Okay, so researchers from a university in Durban went to investigate claims that the mean rainfall during the flooding was more than 140 millimeters. Consider the following information. N is 30, X is 165, standard deviation is 76, mean is 140, or the null hypothesis says it's going to be 140. Alternative says it's going to be bigger than 140, and for alpha is 0.01. Okay, so let's quickly, degrees of freedom, 30 minus 1 is 29, so that is correct. The test statistic is 1.8. Ooh, that we need to calculate. So let's first see the critical values, the one that we will look for on the table. So I would probably look at that one nearly first to see if that can't be the one. Let's just look at, so test statistic, that one. We do not reject H0 at a 1% level. There is enough statistical evidence to conclude that the mean annual rainfall in Durban during the flooding period was more than 140. Okay, so we're basically accepting that. So we will accept that when that is bigger than that, which it is, because, okay, so I'm now trying to, because we're looking for the incorrect one. So let's quickly check. So we do not reject null hypothesis, we do reject. Okay, so let's quickly first get to work out this. Okay, so if you go to your tables, degrees of freedom is 29, alpha is 0,01, so that value is 2.462. So that one is correct. 2.462. So that straight from a table where the degrees of freedom is 29 and the alpha is 0,01. Because we are working with a one tail, you don't divide that by 2. So if we go straight to the table, that is what we get. Okay, so let's calculate the, I just want to draw this here. So if that is my t-stat that I'm working out, if that is my critical value, so if my t-stat is smaller, I reject. If it is bigger, I accept. Okay. So basically this one say I will accept it. This one will say we do not reject it. So so let's quickly see, does that make sense? So we do not reject null hypothesis. We accept the null hypothesis. Ah, sorry. Yeah, I made the mistake. Ish. Sorry about that. Come on. I was now looking at the other. So if it is smaller, we accept. I was looking at the alternative hypothesis. We accept H0. So if it is smaller, we accept that there is not a difference. If it's bigger, we accept the null hypothesis. So we reject, we accept the alternative hypothesis. So we reject the null hypothesis. Okay. And I think that this is, so if it is smaller, we accept the null hypothesis. If it is bigger, we reject the null hypothesis. If we reject the null hypothesis, we basically accept the alternative hypothesis. Okay, so if we do not reject that is basically the same as we accept it. So the test statistic 1.8 is also correct. So then we know that we do not reject it. So that is also correct. So the incorrect one will be option 5. Okay, so you basically have all that one will be wrong, all that one will be wrong. And because of the information given, because it is smaller, we accept the null hypothesis. So we can say that the rainfall is not more than 140 millimeters. So it is smaller. Okay, so we basically have option 5 as the incorrect one. Okay, I talked about bit, as they say in Afrikaans, die mekaar now, so that was a bit confusing, but basically what we need to understand here is if your test statistic is smaller than your critical value, we accept the null hypothesis. If your t-stat that you calculated is bigger than your critical value, then we will reject the null hypothesis. Rejecting the null hypothesis is exactly the same in terms of meaning as accepting the alternative. Okay, happy with that one. Okay, so let's quickly see if we can work some of the others out as well. I think we've got 3 questions left. We've got 3 questions left, so let's do that. Suppose the South African Home Affairs Department wants to determine whether there is relationship between country of residence and gender among, so okay. And then they tell us which one is incorrect. Okay, so first I'm looking for degrees of freedom because that's the easiest one to calculate. So that for me is always easiest one to calculate. So let's look at that. So it is, how many rows do we have? -1, so that's 2. How many columns do we have? 2 minus 1 is 1. So degrees of freedom should be equal to 2. Okay, so that's your incorrect one. The easiest one, so I always look at degrees of freedom first before I even need to start making other calculations. But let's look at the other options. Null hypothesis is always the independent one, so that is correct. The alternative hypothesis is always the dependent one, so that one is also correct. How do we work out the expected frequency? So let's look at what's the expected frequency of females living in Australia. So females living in Australia. So the formula that we use here is we take the sum of females, 260, we multiply it by the sum of Australia, which is 102, and we divide by the total, which is 580. So that is what you would expect the frequency will be for that cell. So that would have been 45.72. Okay, so that is what you would have expected. That is correct. If we do the same for females living in New Zealand, that would be your answer as well. So it was also the correct one. Again, with this one, what I normally do is to see which ones I don't need to do a calculation for, and I will look at that. So I normally go to degrees of freedom first, then I would go to my two hypotheses to see if that is correct, and then only would I start to make calculations. Okay.
Yeah.
Yes.
Sorry, just a question on the degrees of freedom. Should
Yes.
the calc be rows minus 1 multiplied by your columns minus 1?
Yes. And the
Including
other
your totals or excluding your totals?
excluding your totals. So
Okay.
basically what the formula is actually the number of variables that are in your rows minus 1 times the number of variables in your columns minus 1. So it is the 3 variables minus 1 and the 2 variables. So you always exclude the totals when you do that calculation.
Okay, cool. Thank you.
Okay, and I think that's also important because sometimes there has been exam papers where they don't include the total and you need to write it in, and then suddenly you think there's an extra one in. So yeah, but it's always excluding the total. Okay, so now we have 2 more to go, and hopefully this is okay. Let's see if this is an interesting one, because normally I would have used data and put it in a calculator, and it doesn't seem like it. So following the natural disasters in the Southern Africa, the South African Weather Services was tasked with monitoring climate change trends. The simple regression equation R squared is equal to 0.27 explains the mean temperature in the area. Which one is correct? Okay, so the value of y when x is 0 is 46.75. So let's look at it. When x is 0, that basically falls away. So your value should be 47. So that one is incorrect. Okay, so let's look at the next one. The coefficient of correlation is 0.52. So what is your coefficient of correlation here? How do you work out the 0.52 to see if that is correct? Okay, so what is R and what is R squared? So that is the, so which one is coefficient of correlation, the R or the R squared?
The R. The R is coefficient of correlation.
Okay, so how do you then calculate the R? You basically take the 0.27 and you square root that. And then your coefficient of correlation is 0.2 or 0.52. Okay. Okay, so that for me is nearly, you need to know which one is coefficient of correlation, and the R square is the coefficient of determination. So if I, okay, so coefficient of determination is always negative. No way, it's always positive because you have the square. So that one is incorrect. The coefficient of correlation is always positive. That's also incorrect because it can be positive or negative. And then 27% of the variation in y is explained by x. So is that true or false? Okay, so very interesting. So that is also correct. Okay, so here is the trick. Okay, so that one is also correct. So if you look at the negative, so there's a negative correlation between the x and the y. So your coefficient of correlation is 0.52, but it is negative 0.52. So that one is actually incorrect. Okay, so that was a trick one, because I would have, in my exam, I would have stopped there. I wouldn't have gone on to even look at the other ones, because I would have said 0.27, the square root of that is 0.52, and that was my answer. But because the correlation is negative, that needs to be minus 0.52. Okay, so this one really a tricky one, because I would have stopped there. But option 5 is actually the correct one, because 27% of the variation in y is explained by x. Scary. Okay, option 2 was also incorrect, because it needed to be negative 0.52. And the reason why we say negative, because the correlation here is negative. If that was positive, it would have been automatically a positive relationship. Okay, this one would have taken me out, because I would have not even looked at the other two, to be honest. Okay, so let's look at the last one, and then we can wrap it up. If a coefficient of correlation is 0, then the slope of the regression line is 0. The coefficient of determination is 0. There is no relationship between x and y. Sure. Okay, what would you guys say? If coefficient of correlation is 0, the coefficient of determination is 0 as well. So at least we're sitting with those as options when we need to, if we're going to guess. Okay, so let's look at, if that is 0, then there is no relationship between x and y. So that for me is also correct. Do you guys agree?
Yes.
Yes, I agree.
Okay, so
I
let's
think maybe
see.
option 3 can be the answer.
Okay, so then it is, there's B, there's C. Okay, so then that is the correct answer, because that's the only one. The slope of the regression line is 0, which is also going to be correct, because there is not going to be a relationship, so there is not going to be a slope, so that is also going to be correct. I'm now wondering, Yeah, because it must be. I'm just now thinking there is no relationship between X and Y. That is correct. So that is definitely correct. That one I was wondering about. But it nearly feels that is the only option it can be. So are you guys also in agreement that that one is 0? Yeah, it is. This is, again, it was a tricky one. Because again, it is asking for definitions, but it's definitely that one. So if they gave me an option of only B and C, I would have also started to wonder. But we also need to remember that because there's no correlation, because there's no relationship, there is also the slope of a regression line is 0 because there isn't a slope that we work with. Okay, so that is then option 3, and that is it from the mock exam. Okay, so I will save this and send it to, well, obviously it will now also be on the we'll make the copy a video again and post it on Google, but I will also send this to the chat group as well to add it there when you have it on your phone as well. Okay. So that is it. And then what I said at the beginning to the guys as well. So I'll set up time on Monday for just a check-in. So if there's anything on Monday that is still bothering you that we need to explain before the exam, we'll do that. But also use the WhatsApp the whole time before the exam. If there's anything that you need to get clarity on, please ask. That's why I'm here, and that's why the group is here as well to assist. So please ask questions. We've got a few days left and we want to make sure everybody passes, so let's use it and ask. Okay guys, good luck for the last few days before you write this.
Well, thanks, G.
Cool.
Thank you so much.
Okay, great guys, have a good evening, and yeah, I'll chat to you again on Monday, but we can chat on the group as well. Okay, cheers guys, have a good evening.
You too, cheers.
Thank you, bye.
Right.